So welcome you to today's tutorial. If you have any doubts, you may ask any doubt from the homework problems or any of the doubts from the lecture notes or one of the lectures which I did. So the house is open for you. Feel free to ask anything under the sky.
So, sir, from the homework 2,
Yeah.
can you please share the screen?
So which problem you are talking about? You tell
Yes,
me.
sir. So, problem number 2 and part B.
Part B.
Yes, sir. Sir, actually, we know that the whole order statistic.
Yeah.
So this is always sufficient for the parameter.
Mm-hmm.
So do we need to tell anything else for the supporting statement?
Order statistics is sufficient always is not a correct statement. Why order statistics is sufficient? Can you modify your statement? I'm telling you your statement is not correct. Order statistics may not always be sufficient. In this case, it would be, but in general, it may not be. Why? Can you give me a situation where order statistics may not be a sufficient statistic?
No, sir, I can't recall.
Okay, so let me clarify this because this is a very fundamental doubt and it should be clear to you. Now note that why order statistics. So you have to recall what I had said was if x1, x2, xn so if x1, x2, xn is a random sample, what does random sample means? It is IID, right? So it is very important that you have a random sample, that means it is IID with PMF or PDF, as the case may be, let us say f theta, and there is only one parameter. So they all have a same PDF. Then G theta x, that is a joint PDF of, then joint PDF of the whole sample. Because they are IID. So first of all, they are independent. So it is product. And they are identically distributed. Each of them has a same PDF f theta. So this theta is same. F is same. F theta xi, right? That is what it is. Now what is happening is it is the same f theta. So you can rearrange these terms because this is f theta x1, f theta x2, and f theta xn. Now, since it is the same f theta, one of them would be having a minimum, one of them would be having a maximum, and so on. So this can be written as f theta of x1, f theta of x2, because it is the same f theta. So now by factorization theorem, this is same as psi of theta and the order statistic into hx, which is 1. So by factorization theorem, this is sufficient, right? So what is important over here? Important thing was that they were identically distributed. It was the same f theta. If it was not the same f theta, I would not have been able to arrange them like here. I can write the smallest one first because here all xi's are being taken product in the product f theta x1, f theta x2, x2. So I can put first and you know that A cross B is same as B cross A. So I can first take the f theta x1 and then f theta x2 and f theta x. So identically distributed here played a very important role, and of course independence. So order statistic may not be, for example, if x1 has, let us say, exponential theta 1 and x2 has exponential theta 2, then what is your f theta x1, x2? Here theta is your vector, theta 1, theta 2. And suppose they are independent. So your joint PDF, this theta is a vector, x1, x2, would be how much? The density of x1 at the point theta 1, so 1 by theta 1, e to power minus x1 by theta 1. 1 by theta 2, e to power minus x2 by theta 2. If x1 positive, x2 positive, 0. Otherwise. Now, in this case, I cannot write down this in terms of order statistics because I do not know theta 1 is corresponding to the minimum or theta 2 is corresponding to the minimum order statistic. If it was the same theta, I could have written e to power theta x1 order statistic. So in this case, order statistic is not sufficient. In fact, you can show that it is not sufficient. In fact, you can show that minimal sufficient statistic is x1, x2. Again, you can show that f theta x upon f theta y is independent of theta if and only if x1, x2 is same as y1, y2. Is that clear? Does that clarify your doubt that order statistic may not be always sufficient? It will be sufficient when you have a random sample. Then you can always say that order statistic is sufficient. Of course, in this example, order statistic was sufficient, so you could say that.
Yeah, so ID is the key point.
Yeah, ID is the key point. Because of that only, this product f theta x1, f theta 2, x2, and f theta xn, I was able to write down that as f theta in terms of order statistic. I'm not able to do that over here. Is that clear? Yes, any other? So yeah, so now what is your doubt? So yeah, one thing is because here you use a random sample, you can say it is always sufficient, right? But what is the question? Yeah, so that statement is nothing is wrong. That is perfectly all right. But you see, what I expected was here you can also show that you can alternatively show that this, because I know in this problem what I know is you know that if T is sufficient and T is a function of U, then U is also sufficient, right? Now in problem 1, you have already shown that product xi and product xi and product 1 minus xi is sufficient, right? That you know. So if you can show that this is a function of U, you are done, right? But note that this is same as here all products have been multiplied, all xi's have been multiplied. So that is same as product of order statistics. I can take the product in a different order. Is that okay? Like product of 1, 6, 2, 9, right? This product is same as 1 into 2 into 6 into 9. That is what I'm doing over here. Same thing over here. Because here all 1 minus xi's are coming. So I can take as well the all order statistics 1 minus xi. Is that okay? The product are same, which is same as product I is equal to 1 to n ui, because u was u x1, x2, xn, and this is same as product I is equal to 1 to n 1 minus un, where ui is basically u is u1 into un, which is x1, x2, xn. So what you saw that here t was sufficient, that you proved in part A, and t is a function of u. And you know that if t is sufficient and t is a function of u, then u is also sufficient. Is that okay?
Yes, sir. Perfect.
So this way also you can do it, right? And your argument is also correct, that since it is a random sample, order statistic is always sufficient. So both of them are fine. Yes, any other doubt anybody has?
Yes, sir. For the part C of problem number 3.
Yeah. Part C of problem number 3. Yeah.
3.
Yeah.
So, sir, I have tried this. Can I share my solution?
Sure. Let me see. I'll have to allow you to share your screen. Let me see. Yeah, you can share now your screen. This is 3C. So probability x1 less than or equal to x1, x2 less than or equal to x2, and then x2 lies between t minus h to h. You have to put a limit h going to 0. That is okay. Limit h going to 0. x1 less than or equal to x2. x2 lies between t minus h to x2. x2 between t minus h to s. So x1 less than or equal to x2. Okay, that is perfectly fine. Fx2, that is perfectly fine. Probability x1 less than or equal to x2 less than or equal to t, that is also fine. Then probability that x1 is less than or equal to x1, x2 less than or equal to t means each of them is less than or equal to t. So x1 less than or equal to minimum of x1 t, x2 less than or equal to minimum of x1 t, minus x1 less than or equal to minimum of x1 t minus h, x2 less than or equal to minimum of t. ठीक है, okay, then limit h going to, so they are independent, so this is okay, that is fine. Okay, then what happens? I can't see your right hand side. If x1 is t or x2 is t, because you'll have to consider a few cases separately. If x1 is t, then fx what you have written? If x1 is t, what about other x2? What about other x2? This is only x1 is equal to 2. You have to give a range of other xi's also, right?
So here is the confusion, how to write that.
Yeah, so that is also up to this point. It is okay. So let me write it down, and then I can go from this point. Okay, I can.
So should I stop my sharing?
Yeah, you can stop your sharing. So I can do it for the benefit of everybody. So this is problem number 3C. So problem number Problem number 3C of assignment 2. Your x1 and x2, two observations only. IID uniform 0 theta. You have to show that Tx, which is maximum of x1, x2, is sufficient by conditioning, right? Yeah, you have to show that by conditional distribution. So what you have to show is conditional distribution of T, conditional distribution of x1, x2 given T is independent of theta, right? That is what you have to show. So I try to look at f of x1, x2 given T when x1 is at x1, x2 as x2, and T as T. So which is same as probability that x1 less than or equal to x1, x2 less than or equal to x2, given T is equal to T. Now, by the definition of a conditional distribution, you know that, because I do not know whether it is continuous, discrete, because maximum is given. So maximum could be one of x1, x2 also. So it is not going to be that simple to decide whether it is continuous or discrete. So this same as limit s going to 0. So I apply just the definition of a conditional distribution. Given that T lies between T minus H less than or equal to T, which is same as limit H going to 0, probability that x1 less than or equal to x1, x2 less than or equal to x2, T minus H less than T less than or equal to T divided by probability that T minus H less than T less than or equal to T. So what I do is I divide and multiply here by H. So this becomes 1 by limit H going to 0 of probability that T minus H less than T less than or equal to T by H. And that H I have multiplied over here. So limit H going to 0, probability that x1 less than or equal to x1, x2 less than or equal to x2, T lies between T minus H less than or equal to T divided by H. Is that okay? This H and this H will get cancelled and you exactly get at this. But by definition, this is same as FTT, the density at point T, right? Density at point T, because this is same as FT of T minus FT of T minus H by H, which is same as PDF at point T, times limit H going to 0, probability that x1 less than or equal to x1, x2 less than or equal to x2, T less than or equal to T minus probability that x1 less than or equal to x1, x2 less than or equal to x2, T less than or equal to T minus H divided by H. This is same as 1 by FTT, limit H going to 0. What is this? T is maximum of x1, x2. Maximum of x1, x2 less than or equal to T means each of them is less than or equal to T. So that means this is x1 less than or equal to T as well as x2 less than or equal to T. But x1 is less than or equal to x1. So that gives you, the joint event will give you probability that x1 is less than or equal to minimum of x1 and T. This will give you x2 less than or equal to minimum of x2 and T minus by the same thing, maximum less than or equal to T minus H. That means each of them is less than or equal to T minus H. So x1 less than or equal to minimum of x1 and T minus H. and x2 is less than or equal to minimum of x2 and t minus h divided by h, right? Now note that I write down this in various forms I make various branches. First thing is, if x1 and x2 both are less than t, what happens in that case? In that case, this would be how much? Probability x1 less than or equal to x1 multiplied by their independence, so probability x2 less than or equal to x2. What would be this quantity? Anyone? Anyone? What would be this quantity if x1 is less than t as well as x2 is less than or equal to t? Now note that if x1 is strictly less than t, let us take first the x1. Actually, this first you can write down as a product because x1 and x2 are independent. So this is probability x1 less than or equal to x1 t multiplied by probability x2. So I can write down this as a product minus probability x1.
But I think it will depend on age.
Yeah, but note that h is going to 0, h is not 0. And I can make h as small as possible. Right? So what you have is, let us look at x1 is over here and t is over here. x1 is strictly less than t, whatever it may be. Now note that when you have a t minus h, I can take h arbitrarily close to 0 so that t minus h is very close to t and bigger than x1. Because finally h is going to 0. So I can choose h as small as I wish. So in this case, x1 would also be less than t minus h by taking h small, arbitrarily small, because h is going to 0. So that means when x1 less than t, x2 less than t, this would be same as this quantity only, probability x1 less than or equal to. So this would be 0 if x1 and x2 both are less than or equal to t. Second thing is, if x1 is less than t, but x2 greater than or equal to t. x1 less than or equal to t, what does that becomes? This would be, yeah, f of t. x2 is greater than or equal to t. So what would be this quantity? F of x2 minus. Now since x1 is less than t, I can choose a h arbitrarily small so that x1 is less than t minus h also. So this would be f of x1 again. And then since x2 is greater than or equal to t, x2 would be bigger than or equal to t minus h also.
F of t minus h.
So this would be f of t minus h. Yes, let me just say, if x1 is less than t, then this is f of x1, sorry, let me write down. Note that what I've done is x1 less than t, but x2 greater than or equal to t. x1 less than t, that means this is f of x1. x2 greater than or equal to t, this is f of x2. x2 greater than or equal to t, minimum would be t, f of t. Minus x1, since it's strictly less than t, I can choose t minus h by taking h arbitrarily close to 0 so that t minus h is bigger than x1. So in this case, this would be again f of x1. What would be the minimum of x2 and t minus h? Because x2 is bigger than or equal to t, so x2 would be bigger than or equal to t minus h also. So f of t minus h divided by h. So f of x1 goes outside, and what does that become? Into the density f of t. Is that okay? Then similarly, you can look at x1 less than t. Now x1 greater than or equal to t and x2 less than t. What would be this quantity? You can look over here. X1 greater than or equal to t, that means t is minimum. Right? So this would be f of t. What would be this quantity? Since x2 is smaller than t, so it would be f of x2. Since x1 is bigger than or equal to t, x1 would be equal to t minus h also, it would be f of t minus h. Since x2 is less than t, I can choose h arbitrarily small such that x2 would be smaller than t minus h also. So f of x2 divided by h. So f of x2 becomes common, and you get f of x2 into density of ft. Is that okay? Now what happens if x1 greater than or equal to t as well as x2 greater than or equal to t? What would be this quantity? If x1 greater than or equal to t, x2 greater than or equal to t, this would be ft, this would be ft, this would be ft, this would be ft, so this would become 0. There is some problem somewhere, right? X1 greater than or equal to t and x2 greater than or equal to t. How much that becomes minimum? We will do that f of t, f of t or minimum you're talking about. So it becomes, yeah, how much?
ft times ft minus h times ft minus h.
ft into ft, right? Both would be ft, right? F square t, right? Minus, and what would be this? F square t minus h. Is that okay?
Yes, sir.
Divided by h and limit. Right. Now let us look at, this is independent of theta. What is FTT? The distribution of FTT, you know, it is a maximum. And t to power n minus 1, so 2t
By theta square.
by theta square. For t between, so 2t by theta square. And what will be this quantity? x1 by theta, and this would be 1 by theta. So x1 by theta square, and this theta square would get cancelled. Similarly, over here, this theta square would get cancelled. And what would be this quantity? This is same as ft minus h into ft into ft. So 1 ft into ft minus h will give me a density. And the second one will give you 2 times f of t, because that would be ft plus ft minus h. Right? So this again would be t by theta, 1 by theta, theta square would get cancelled. Is that clear?
Yes, sir.
So all the ranges are covered, and you have shown that distribution function is independent of theta. Is that clear? Any doubt in this? Actually, this limit, what I've done is I have written down this as ft minus h into ft plus ft minus h, right? Divided by h. I take h along only with this. When I take h with this gives me a density, right? Limit h going to 0. What does this gives me? Limit h going to 0 because f is continuous. So limit h going to 0 of ft minus h would be ft only. So this will give me 2 times ft. That is how you get over here. Is that clear?
Yes, sir. So should we go for after that the PDF approach? I mean,
No, distribution
or
function is independent of theta. So PDF would also be independent of theta.
okay, so that suffices. Okay.
Yeah.
And sir, for the problem number 4,
You can
part
get,
C.
if you want, you can get a PDF from here, right? You know how to get a distribution. Now note that this has a jump at point t's, right? That you can see x2 greater than or equal to t, it gets you something else, right? So now you have to get, so that means there are jumps at point t. So that means your exercise can take value t also. So you can talk about probability x1 less than x1 is equal to t, and then the density of x2, right? For example, you can talk about what is the probability x1 is equal to t and x2 less than or equal to x2. Is that okay? See, what I'm saying is you can talk about here. So this will be a mixed kind of a density. So let me write down. So probability x1 is equal to t and x2 less than or equal to, let us say, x2. Is that okay? Now this is same as probability that x1 less than or equal to t, x2 less than or equal to x2, minus probability that x1 less than t and x2 less than or equal to x2. So these are left-hand limit, right? What would be this quantity? So let us look at when the first one is t and t minus. So that means you have to right. So this you can get from here. So one thing is when one is t and second is x2. X2 could be anything, right? So one is t, that means I have to take this range, right? In the first one. And when x2 is less than t, so you can get this probability from here. So you'll see that this is something. So what you would see is x1 can take a discrete value, but x2 would be a continuous kind of a thing. So it is a mixture of the discrete and continuous. So try to find it out. Although for the purpose of this question, just showing that distribution function does not depend on theta is good enough. But for better understanding, I will advise you to look into what is the probability mass function. It will be a mixture of a density and mass, because x1 is taking discrete value, but x2 will take then values in a interval. X2 would be a continuous part, x1 would be a discrete. Similarly, you can have a situation where probability x1 less than or equal to x1 and x2 is equal to t. Is that okay? If you allow me, I can just see, let me see. Yeah. Let me just make some space so that, okay. So let me erase this. Okay, so So let me use, oh, still it is. Yeah, so let me use what is a probability that x1 is equal to t and x2 less than or equal to x2, right? This is same as probability that x1 less than or equal to t, x2 less than or equal to x2, minus probability that x1 less than t, x2 less than or equal to x2, which is same as f of t comma x2. And what is this? This is x1 less than t. So it is f of t minus x2. Left hand limit I'll try to look at. Now try to see when x1 is t. That is the third case, first, second, third, right? So this corresponds to the situation where x1 less than t, x2 less than t. This corresponds to the situation where x1 is less than t and x2 greater than or equal to t. This corresponds to a situation where x1 greater than or equal to t and x2 less than t. So f of t, x2, if x2 less than t, would be how much? F of, yeah, f of x2 into f of t. There would be a ftt, and then x2 is less than t and t minus. T minus, basically what I'm talking about this. So this would be 0. And there was ftt anyway, everywhere in the denominator, so ftt. And what would be for x2 greater than or equal to t? x2 greater than or equal to t, that means ft x2 would be nothing but 2 of ft into ft. Right? x2 greater than or equal to 2 of ft into ft, and then minus t minus. T minus is this quantity, which gives me f of t into f of t, because x1 less than t, f of t, and then ftt. So that is what you get, f of x2 ft. This was a distribution of maximum. Maximum, you know, is nothing but 2 times ft into ft. And this would be ft into ft divided by 2 times ft into ft for x2 greater than or equal to t. So this gets cancelled. This you are left with 1 by 2. Right? So you can now get the density. Probability x1 is equal to t and x2 is equal to t. So you can get the density of what is the probability of x1 is equal to x2. So f of t and x2. So you have to just differentiate it at the point x2. So what would be that? If t is half, t is equal to, yeah, so x1 is equal to t. So what is the density you get? Here it is anyway 1. So this is 2 times ft upon 2 times ft. So ft gets cancelled, right? So you get f of x2 by 2 times f of t and 0 otherwise. Similarly, you can get f of x1 and t, because it gives a weight x1 is equal to t also. So it is a mixture kind of a distribution. Okay. Anything else you have? Any other doubt?
Sir, problem number 4.
Problem number 4, yes.
If you look at the part C, there is a statistic like T4 X car, which is a quadratic form of TX car.
Right.
So if we somehow encounter this kind of things like quadratic or cubic type of equations on TX card, so we can't find any unique solution of it.
So you see, any of these sufficient, because you have found out a minimal sufficient statistic, right? So if any of them is sufficient, then your minimal sufficient statistic should be of function of this, right? Because minimal sufficient statistic is a function of every other sufficient statistic. Is that okay? So now let's try to see what kind of a relationship between T4 and T square is. T4 is given to be T square plus 3T plus 2. What kind of a function T square is of T4? So it is 2T plus 3. 2T plus 3, and T can take values anything. No, T is always positive, right? T is always positive because xi's are between 0 to 1. Your xi's always take value between 0 and 1. So minus log xi would always be greater than 0. So Tx, which is summation I is equal to 1 to n, minus log xi would always be positive quantity. Is that okay? Now, if this is positive, then dt4 by dt, if I take the derivative, it becomes 2t plus 3. Because t is positive, so this would be strictly greater than 0. Is that okay? So what does that mean? T4 is a strictly increasing function of t. Now, if it is a strictly increasing function of t, you can get their one-to-one function. Right? What does that mean? That means t is a function of T4. In fact, they are one-to-one correspondence. T and T4 are one-to-one functions of each other. And you know that any one-to-one function of a minimal sufficient statistic is minimal sufficient. So if your T was sufficient, T4 would be minimal sufficient. So in fact, forget about sufficient, T4 is minimal sufficient. Is that okay?
Sir, here sufficiency is only considered, not minimal sufficiency in this question.
That's okay. I have concluded something more.
Okay, okay.
Minimal sufficiency anyway, any minimal sufficient statistic is sufficient, right?
Yeah, of
So
course.
it is certainly sufficient. Is that okay?
Yes, sir. So we can go for this derivative kind of approach, and we can.
Yeah, if you can, so you see, I needed little only less than this. What I needed was, I have shown something more. What I needed to show was T is sufficient, right? So what I needed to prove was T4 is a function of T. Sorry, T is a function of T4. Now, you know, because we know that if T is sufficient and T is a function of T4, then T4 would also be sufficient. So what I needed was T is a function of T4. What I've shown is T and T4 are one-to-one function, in fact. So they are function of each other. So here I've shown that.
If T if T somehow takes the negative value in not that case,
then it will not be.
yeah.
Then it will not be. Is that okay? Then
Yes,
in fact,
sir, perfect.
then it will not be sufficient, because if it was sufficient, then I should be able to get T4 from T, right? Because T4 then should be a function of T. But since T is taking negative values, then what would happen is it would be increasing only for T greater than minus 3/2. Before minus 3/2, it is a decreasing function. And T is equal to minus infinity, it is infinity. So it may come like this. And this may be T4 as a function of T. So if you are given a value of T4, there could be two different T's. So I cannot determine T exactly from T4. So T4 is not T is not a function of T4. Is that okay?
Yes, sir, understood.
Yes, any other doubt? So I wanted to make a few corrections in this assignment number 2. Please note down those corrections. Problem 1, part D. I have given theta to be R. So this you have to cut. You have to take theta to be 0 infinity. Right? I cannot take theta to be R, because then theta is equal to 0 would be included and variance 0 would be included. That's a problem. So I've taken theta to be 0 infinity. Similarly, problem 2. D, there is no third component over here. It has only two components. Ux is x bar and summation I is equal to 1 to n xi minus 1 whole square. I have given xn also. So you just cut this and you take ux to be the first component, first two components only, x bar and summation I is equal to 1 to n. Is that okay? Do you have any other doubts? Anybody? Any other doubts which you may like to ask? Any doubt from the lectures? So how are you finding the stuff? How are you finding the course? Is it going okay so far?
Yes, of course.
Yes, sir.
Okay. So feel free to ask anytime. If you feel that I'm going fast, you can always ask me to slow down. But I expect your active participation in the conduct of whole course. Then only we can make this whole learning experience enjoyable. Otherwise, but this is a very interesting course, and you learn a lot of things, not only related to your estimation and testing, but a lot of stuff related to your probability and distributions. For example, this case, the one problem 3C, which we discussed today, it was a very interesting distribution, which was neither fully continuous nor fully discrete. It had a component of a discrete and a continuous. X1 was taking a discrete value and X2 in intervals, and vice versa. So try to look into those things and you'll find them interesting. They give you more insight into probability and distributions. Okay, any other questions anybody has? Okay, if there are no questions, then we may disperse. And if anybody wants to stay back for asking questions, he or she may stay back. Others may leave. Okay, Bidisa or Guglot, do you have any questions? Vidisa? Guglot, Novya? Seems you're not there. So let me finish the meeting then. Since none of you have any questions, let me just finish the meeting.